Hey everyone, my name is Mark Kleider. I'm a product manager with Amazon Redshift. I've been with the team for about 4 years now, and I'm very excited to be here today with you to talk about Amazon Redshift, specifically how you scale data analytics with our service. And today with me, we have Matt and Kurt from Warner Brothers, and they'll share their experience with Amazon Redshift, their insights about how to build scalable data analytics stacks with Amazon Redshift. We're seeing three common trends when we talk with our customers. The first one is that more than ever and faster than before, they're migrating to the cloud. They want to realize the benefits of the flexibility, the performance, the scale, the cost efficiencies, and the ease of use that come with the cloud. More than that, they have exponential data growth that they're experiencing from IoT, wearable devices. Social and mobile trends also contribute. And customers understand that in order to gain valuable business insights, they need to analyze their data end-to-end in order to serve their customers and take business decisions based on all of their data. Customers tell us that their on-prem systems and other vendors that they use create some challenges when it comes to different data sets coming at different volumes, different velocities, different speeds, different file formats that they need to process. When they see value in data and they onboard more users, they actually experience degradation that is counterintuitive because performance and the concurrency of their queries is actually not supporting their needs. They have multiple different teams that want to collaborate on the same data set. Imagine a machine learning focused team, data science team, QA, product, marketing, finance. They all want to collaborate on the same data sets. And they need to have easy access. And more than that, it needs to be secure. So everyone gets the needful access and not more than that. And security needs to be top of mind, integrated into the product, and not cost customers more in order to secure their data. They're also asking for flexible, innovative cost structure that enables them to start fast without committing unless the use case is actually meaningful for them. And they want this predictability in cost so they can plan ahead. This is why they migrate to Amazon Redshift. And today, we have tens of thousands of customers that are using our service and collectively process exabytes of data every day. One of the most important aspects of the service is the native integration, as you'll hear more about in this session, with the data lake, enabling our customers to query all of their data, whether it's stored in the warehouse or it's stored in the lake. With the lake formation integration that we have, they can also specify the access controls that they care about. Redshift provides the best performance, 3x better than the other vendors. And what it means is that you can gain insights faster to serve your customers and also gain this competitive advantage. Lowest cost means that Redshift is 75% less expensive, right, than other vendors. And when customers commit to long-term use of the service, they get even further steeper cost savings. Redshift is scalable. As you heard about during the keynote, we now scale storage way more, and you pay for it separately, and we'll talk about it in a bit. You can also scale the cluster resources that we had with concurrency scaling, and you can extend the analytics of your cluster to the lake with the same tools that you're using today. Security and compliance are coming out of the box in a native fashion. You don't need to pay more for that. And the service as a whole is fully managed. This means that we take care of all the operations that you care about, but don't really differentiate your business. This includes a new version upgrade that we deploy to your clusters every 3 weeks on average with new features and enhancement that drive your workloads even faster. I want to touch upon the first point of data lake with this visual that conveys what our customers are doing with the data lake. So they have one foot in the warehouse with highly structured data, performant workloads that run on top of Redshift, while they're able to access all of their data in the lake and join the two and make sense of the two in a unified, easy-to-use fashion. What this means is that you can store, for example, your marketing data in Redshift, and all of your sales data, historical, recently arriving data, event, operational data in S3, and join them as part of your data lake architecture, join them together to gain business insights that are not possible otherwise. We call it the data lake architecture, or the lakehouse approach. The architecture of Redshift is simple yet very powerful. It's an MPP, massively parallel processing, shared nothing, columnar architecture. On the top, you see the leader node. The leader node talks standard ODBC, JDBC over the wire, so we connect with common BI and SQL applications. This is where in the leader node we compile your query, optimize it, and distribute it to the compute nodes to process your queries. And these compute nodes can actually leverage a massively scalable compute layer called Spectrum to query all of your data in open file formats like Parquet and ORC directly in S3. This is a sample set of our customers who use Redshift and the data lake for a long time now. And you can see here a variety of customers from different industries, from financial services, healthcare, retail. And the interesting part about this slide and about our customers as a whole is that many of them start actually very small with hundreds of gigabytes, right? And they scale as they need to on demand within a click of a button to 8 petabytes per one cluster, and you can have as many as you'd like, in addition to be able to query all of their data in the lake out to exabytes, as we introduced in 2017 with Spectrum. I want to change gears a bit and talk about the what's new, the stuff that is new and exciting that was just announced today at the keynote in a bit more detail. This slide summarizes the innovations, the key innovations that we had in 2019. And we had over 100 significant features and enhancements to the service in the last year. In this slide, I included the innovations that I feel that are going to matter to you as you build your scalable data analytics stack with Amazon Redshift. First, we'll talk about performance. And you'll see that with the new exciting instance type that we announced today, RA3, the third generation instance type, that enables you to load as much as you'd like to the cluster, scale storage separately from compute, and pay for them separately, we're introducing a new level of performance and cost efficiencies. Aqua, or the Advanced Query Accelerator for Amazon Redshift, is a custom-built hardware layer that can process queries 10x faster. With the custom-built encoding algorithm, AZ64 that we launched, and many others, we make, including concurrency scaling, we make your cluster and your investment in Redshift far more performant to serve your workloads. I also want to call out the federated query capability that we'll talk about in a bit that enables you to tap into more data stores, not only S3. Other than performance and scalability, it is important for our customers to realize the benefits of all these of-use features that we announced in the last several months. This includes a new, fresh console that is very easy to follow to manage a fleet of Redshift clusters at scale. This also includes automated workload management and query priorities to assign cluster resources based on your business priorities. And lastly, I want to talk more about the data lake, where Redshift, being natively integrated with the data lake, enables you to save the data enrichment, the data transformation that you've done in Redshift back to the lake to share with other services. In addition to the ability to define, with AWS Lake Formation, to define specific access controls per your needs. Let's get started with performance. Redshift, out of the box, with no tuning, based on our Cloud Data Warehouse benchmark with 30 terabytes, a pretty significant workload, is now over 2x faster than what it was back in June. This is not a surprise. This is not a single enhancement. This is actually a variety of enhancements that have to do with the compression, AZ64 encoding that I mentioned, with distributed Bloom filters, with better caching for your queries. Each of these enhancements, on average, is deployed to your cluster in an automated fashion every 3 weeks. together, they represent this over 2x faster performance that our customers are now able to realize. With concurrency scaling, the feature that we announced in March this year that enables you to scale query concurrency on demand when there is peak in a workload, we can now drive over 12,000 queries per hour, representing a net benefit of 35x improvement in throughput just in the last several months this year. The interesting part about this feature is not only just the scalability and performance that it brings to your workload to serve queries with no wait time. It is also the pricing that with the free hour that we give every day for 24 hours where you use the cluster and the per second billing only when these clusters are serving your workloads, this is a pretty cost-effective enhancement to the service. As customers bring more data, they have more use cases. We support more data types. We just announced the geometry data type that enables you to natively process spatial data, also ingest and store it. And what it means is that you can now join your business data, your marketing data, with geometry, location-aware use cases. Imagine that you are a large telecommunication company doing operations with Redshift. You can now make sense of the location of your assets, location of your end customers, to gather better insights and drive better decisions based on data. The same would apply to a gaming company doing an augmented reality game, and they can now take better in-game decisions based on the location of the gamers. The newly announced instance type, RA3, the third generation of our service, is built on top of a high-speed cache along with high bandwidth networking. This enables you to get much faster performance than before while being able to load all the data that you need to the cluster, up to 8 petabytes to a single cluster, and pay for storage separately from compute as you scale them per your needs. The nice thing about it is that it is going to work automatically for you with no changes to your workloads. If you're using Redshift today, all you need to do is to resize or restore from a snapshot to get to the new node type. If you are new to Redshift, all you need to do is to launch the new instance type. That's it, and it's going to work for you. It is based on a sophisticated managed storage layer that scales to your needs. Moving on, it's not only about loading more data to Redshift. It is also about Redshift being able to access different data stores. So you know that you can query data in Redshift and in the data lake with the lakehouse architecture that we have. But now, as we announced at the keynote, Redshift can also query Aurora PostgreSQL and Aurora and RDS PostgreSQL directly from your Redshift cluster. You can do this live, meaning that you can join data across these different data sets within the same query and gain these valuable insights coming from your transactional data sets along with your analytical data sets. What it means is that you can tap into these data stores, and if need be, you can easily import data live to your Redshift cluster with ease. You don't need to set up these ETL pipelines anymore. All of this is now offered in preview for you to evaluate, and the preview is open today. Ease of use, as I mentioned, is pretty compelling for our customers when using Redshift. And what it means is that we use sophisticated machine learning technologies in order to benefit our customers, to benefit our fleet at scale. So we learn from your workloads, and we learn how to optimize them based on the patterns that we recognize. And this includes the ability to run the vacuum and analyze operations automatically on your behalf. It also includes the automated distribution of tables and an advisor that works on your behalf and provides you with specific recommendations for your workloads. And the recommendations change with your workload. As you increase your workload, as you bring new users with new workloads, we bring in new recommendations that would matter to you. The last feature that I want to talk about has been the one that most of you here in the crowd were asking for. This is the data lake export that was announced today. And this feature enables you to share data with other services. in an open, optimized file format for analytics. This is Apache Parquet. What you see here on the slide is that the data that you enriched and transformed in Redshift can be easily exported with a single unload command to a bucket, S3 bucket of your choice. And more than that, you can decide to partition it based on a column of your choice. In this example, the ship date of the line item table. What it means is that you can structure your lake and you can get the data that you enriched in order to share it with other services like Amazon EMR and Amazon Athena and SageMaker and many other tools that can open file formats directly in S3. This is live today, and you can use it. With that, I want to turn it over to Matt from Warner Brothers to share their experience with Amazon Redshift. Thank you. Thank
you. Can you guys hear me? Yeah? OK, great. At Warner Brothers, we believe in the power of great stories. And some of our most immersive stories are told through games. To introduce you to some of the stories that we tell, I brought a few friends along. So why don't we take a look? Telling stories like these requires a lot of data. It starts with market analytics, where we look for interesting trends in consumer behavior and consumer preferences, opportunities with intellectual property and new game genres. And we use those observations to determine benchmarks for where we want our own games to perform out in the market. As we develop new stories and get those ready for our players, we use data from the games to help our developers understand whether they've created enough content, whether the economy of the game is balanced, and then ultimately whether the features of the game are performing as they were designed. As we get ready to take those stories live, we work with our advertising and marketing partners to understand whether we're acquiring the right users and getting them at the right volumes that we expect. And then again, whether the game is performing the way that we expect, whether users are retained, and whether they're engaging in ways that we would like. Now, when we start off a new project, what's interesting is that we all start across our teams at a macro level incentivized in the same way. But when we go back to our desks and we start our work to contribute our part of the story, oftentimes different incentives naturally occur. I don't think this is unique to games or unique to Warner Brothers. I've seen this across many other industries, and you may see this in your own world. So for us, the folks that are developing a story, they're not going to ship it, they're not going to share it until it's fun and it's engaging. And sometimes finding that fun, it takes you to places you don't expect. It's a creative, artistic process that happens without constraints. Analytics, on the other hand, is actually deliberately a process that exists within constraints. We define data with taxonomies, we load it into schemas, we index it so that we can access that data with a rich vocabulary. At the end of the day, one of the challenges and a goal for our team is to find ways to measure our business and provide meaningful feedback back to the business without getting in the way of that creative, artistic process. Our business is definitely not static. When we look at how a game goes live and how people receive it, sometimes you don't expect different peaks and different promotions. So to be ready for this wild environment, we think about a couple of things. How do we set up our infrastructure to scale for the needs of the business at any given point in time? How do we make sure the data that we collect is federated with other sources of data so that it's useful and exposed in a democratic way so that folks can make use of it in the tools that they prefer and that they're going to do their best work in? And then finally, why do any of this unless you can take action on it? So we want to make sure we've built out meaningful hooks to take action on that data. So let's start with scale. When we're developing a game, the volume of data that we collect is not necessarily significant. However, it's definitely, the definition of that data is definitely volatile. It changes as that story emerges and as developers find that fun. Features change very rapidly, and the telemetry that we're sent from those games and those features changes rapidly. So we need infrastructure that can respond very quickly to that as well. We need that same infrastructure to scale in preparation for launch. More and more games aren't developing features only prior to launch. There's a live operations that goes into games where feature development and finding that fun is a continuous process. So we need that same infrastructure to scale. We use Redshift for this, and we use elastic resize quite a bit to size and scale our infrastructure to meet those changes in the lifecycle. We use Spectrum to connect our lake house and our data lake, to use the metaphor that was introduced earlier. And then we feed all of this with Spark streaming on EMR. Using micro batches, we have frequent fast data that's loaded into Redshift for our analysts to work with. As time progresses and increased promotions are introduced into the world, some expected and some not, we're able to handle those peaks very quickly using opportunistic compute and storage. So using concurrency scaling, we can absorb periods of emphasis from our analysts and data scientists very easily. And then when the game scales as well, we can absorb the extra telemetry that we receive using the new RA3 instances without having to take on a maintenance during a period of high promotion. We use Presto on EMR right now to federate the data that we collect in our data warehouse, in our data lake to our game servers running in Postgres so that we can combine the player's state with interesting data that we've collected. As games mature and the life starts to kind of flatten out a bit and become more predictable, we start thinking about cost control and management and maintenance overhead. So by pushing more data out to the lake from the cluster, we can simplify the overhead to maintain that data over time. So the data lake export feature is a perfect fit for this. Now, our business, it's not enough to think about the volume of data. We also have to think about the width of it. Increasingly, there's a lot of teams that work together to develop our games and to publish them. And increasingly, they're all bringing their own bespoke marketing technology to the table. It's all natural, and I imagine every industry is dealing with this as well. The challenge with this proliferation of tools is that each one has an imperfect view of our business. They all have their own little analytics suite involved, and they all have different definitions of metrics. So a goal for our team is we integrate all of those sources, bring all the versions of truth centrally, and then we use the imperfections of all of those different versions to create our Warner Brothers version of the truth that we can share back to our teams and to some of our partners so that we're all working from a same consistent understanding of what our business is and a same vocabulary. So in the keynote and earlier in Maur's talk, the concept of a lake house was introduced. I wanted to walk through how we've approached rules for developing our lake house, what goes into the house and what goes into the lake. It starts with game telemetry. So the telemetry we receive from all of our game clients, console games, mobile games, PC, that is by far our most interesting, most accessed asset. So we put that into Redshift for a couple of reasons. One, we want to maximize the vocabulary that we can use to analyze that data. We want to have a single query engine that we can use to reach out to other sources of data in our environment to enrich that as time goes on. And then oftentimes, as our team is working with the data that we've collected, we want to read that data in and then write back some kind of alternate view or aggregate that we've collected. So we can do that right back into the same warehouse that it's sitting. And then as we talked about in the scaling concerns, we can grow and size that cluster as need be as the game increases and moves on. So what goes into our data lake? A couple of different types of data. Largely partner data that we use to enrich that game telemetry, new dimensions to that same data, sales data, advertising data, customer service data. All of that, we bring it into the lake for a couple of reasons. One is oftentimes our lake house isn't one house and one lake. It's a lake with a bunch of houses surrounding it. So we want to share those same feeds across multiple clusters. Spectrum and S3 is a really easy way to make that happen. On top of that, we have many feeds that are real-time, high-volume streams to us that we want to capture that data, but we only read from it occasionally, and that's a really great use case for Spectrum as well. We can put all that into S3, and then we can still access that from Redshift as need be. And as I mentioned a moment ago, as we develop our storage tiering strategy, having more of the long-tailed data that's sitting in our warehouses pumped out into the data lake is a great way to have it still be accessible, but not take on the cost and management overhead within the cluster. As a convenience, we've bridged the two worlds by taking regular modeled extracts from our warehouse and pulling that from our data lake, and pulling that into our warehouse for convenience, so that we have aggregates sitting alongside our game data, and we can access both of those together, provide correlations between them, and access them with the same robust query language that's available. Query vocabulary that's available in Redshift. So last, I wanted to talk about how we take action on this data. This lakehouse strategy has also set us up to use all of those data sources opportunistically to create extracts and cohorts that we want to drive throughout our business. We already today are using Redshift's query engine to pull from the warehouse and the data lake together, write interesting combined extracts into S3, and then we have a series of lambdas for different locations that we want to drive that data to subscribe to those buckets. Increasingly, as we want to drive predictive elements based on that data outward, we can throw SageMaker in the middle and enrich that data coming through. So where do we send the data via these lambdas? Oftentimes, we send it back to the game to complete the loop and enrich the player's experience. And then back to that marketing ecosystem of different partners so that we're completing the loop around in our users' workflows. At this point, I'd like to invite Kurt Larson to come up on the stage, and he's going to share with you more detail about our journey towards this architecture and give you some tips that you can consider on your own journey.
Thank you, Matt. So you just heard Matt spend a few minutes talking about some of the business aspects of our big data stack and how we use it in the business. And I'm going to spend the next 30 or so minutes with you, and we're going to drill into a little bit of technical detail on it. And what I'm going to do that with is I'm going to tell you the story of our journey with the AWS Big Data Stack and try to relate to you a bunch of lessons learned and explain into some more detail what our stack actually looks like. So to start off, a few guidelines. These are basically lessons learned from our experience along the way. I'm going to have some challenges that we faced and some tips that we'll offer to overcome those challenges. So with big data, you always start with the V's, right? Velocity, volume, variety, veracity of your data. You've got to know your data sources. As Matt showed you a few minutes ago, we have a variety of data sources, and they all have different volumes, different variety of data, different velocity. And the organization prior to us integrating our big data stack, had a very different opinion of the veracity of that data or the accuracy of that data. One of the challenges we had to overcome there was we would kind of get stuck down a little rat hole quite often of whose data is better data. So we've turned it into one version of the truth to basically make that roadblock go away. We have many stakeholders across the business. You saw in that wheel diagram that Matt said, there's many different business disciplines and functions within the business. And they all work differently. They all need different data from different sources to do their jobs. And it's really important to understand their point of view on the data, what they need to service them. The tech is very complicated. I'm sure you all know that. You wouldn't be here at reInvent if it wasn't. But you could literally spend the whole rest of your career just trying to keep up. What I'm going to suggest is, if you're starting out, pick a few services, start small, and learn and grow from there. That's exactly what we have done, and many other folks that are on AWS with a big data stack have told me they've done the same. And the data space is very complex. When we first started out, we had about 3 or 4 data sources, relatively small data. Now we have well over 30. Again, start small and simple, pick some high-value data sources with some high-value stakeholders, and delight them from the beginning, and this will go viral for you. It's great when you have customers coming to you asking for more data. They want to use your data. You got to know a few of these topics to be able to build your data stack and understand your problem space. On the ingest side, your internal data sources. For us, it's game telemetry data that we get directly from our game clients, whether that be a mobile phone or a game console or a PC running a game. You got to know what structure is on that data. Maybe it doesn't have structure. And at some point to use that data analytically, you have to find a way to put some structure onto it. Right? I'm sure a lot of you have dealt this. You know, you get the big old blob of JSON. Yeah, and every record is different. How do you make that work analytically? Well, you got to impose some structure on top of it. Each data source has its own arrival tempo. Right? So for our game telemetry data, that data is just streaming in constantly. You know, we're getting 20, 30,000 events per second we're ingesting from our different devices out there in the wild. Some of our data sources are more traditional. Like you look at sales data, some of our marketing data sources, we still get your typical daily either drop or pull of that data from an external partner. And if you want to keep your customers happy, their data has to be durable. So it's really important early on that you make that data durable ASAP. And elasticity is one of the tools you can use for that, and I'll dig into that a little bit more later. Now, you brought the data in, now you have to transform it into a usable shape. You've got a lot of folks on your teams, or maybe you're building a team. You got to know what skills those folks are going to have, and you have to match the tools that you have to the skills, or you have to retrain those folks in the tools that you choose. Either way, you have to match them up. This is the point where you apply any data structure that you may not have from the data source. That's another transform. And if I can make a recommendation here, if you have multiple tenants, and for us a tenant is a game, this is where we try to make that chaos quite a bit simpler for us by trying to apply some standards across all of those tenants. Right? We very quickly got out of the business of deploying unicorns for every game. It just wasn't scalable. On the data consumption side, again, you've got skill sets, but those analysts and the folks consuming the data, for us it can be all the way down to the game developer. You got to know their skill sets. You got to know their access needs. Right? Do they need a SQL endpoint? Do they need something from a reporting engine somewhere? Right? And you got to know the tempo of the data, the tempo of the consumption of the data. Do they just need a report once a day, right? Maybe they need a report once a week to go to their weekly status meeting, or maybe they need that data every hour to make intraday marketing spend decisions, right? The tempo of consumption here has to line up with your tempo of ingestion. And again, multiple tenants. On the consumption side, you have to figure out how to protect those tenants from one another. To tie those together, you got to meet the business process expectations with data flows. Transform dependencies are critical here. If I could give you all one kind of gem to take away today, it would be to kind of abandon the hopeful wall clock timing, right? Don't go into cron and start a job when the prior job typically finished. That will find every way to go wrong for you that it can. So to get past that, you need to have positive flow control. And one way to do that is to use a DAG or a directed acyclic graph. We use a tool called Airflow that helps us do some of that. We use Spark Streaming that helps do other parts of that. And ultimately, you may wind up with what we call a DAG of DAGs, where you've got a very deep tree structure in your job control. And that's what brings order to that chaos of something maybe running a little bit long one day, and a job starts too early, and the data it depends on is not available yet. That's just a rat hole where you'll spend all your time. Now, to make this all realizable and survivable for your teams, you got to measure it, and you got to react to it. So for measurement, you need metrics. Now the services, the AWS services do a great job of providing you kind of common metrics that everybody needs for the service. But your business probably has metrics that you need to build yourself that are specific to your use cases and that you're going to use to run your system. Put some monitoring on top of that. Figure out what normal thresholds are, or maybe you do some anomaly detection on top of that to figure out what things aren't normal, what things you need to actually act on internally to your stack. And then alert on that. And this is how you meet your SLAs with your customers. I'm going to spend the next 15 or so minutes talking about our journey in the big data stack. So we started in 2013, 2 games per year that year, and we're doing your typical daily batch jobs to load our data into Redshift, to do our transforms and so on. And actually then we were using a different popular analytic column store database. We weren't even on Redshift yet. And we started to build what we had then affectionately called our data puddle. 2015 and 2016, our velocity increased on the number of games we were ingesting. Why? Because our customers liked what we were giving them, and other customers within our organization wanted some of that. Okay. We migrated to Redshift, and we started to build what then looked like a data pond. One other thing on that is that we made a big shift in 2015. We went from that batch loading to Spark Streaming. We ran a micro batch interval about 3 minutes. So we were actually running near-time data. Not quite real time, but near time. So if you were to query those tables 3 minutes apart, you would get different results. 2017, 10 new games, 10 new tenants. For us, a tenant is a game. Still running a 3-minute Spark microbatch to run the ingestion. But now we bring in Spectrum, and we're leaving some of that data out in S3 so we don't load it into Redshift. Now we actually have something that starts to look like a data lake. Okay, we actually have 2 kinds. The white one there now, we grew from a data pond, if you will, to an operational data lake. Okay? Operational to us means system of record, but we don't query it. But now we had analytic data lakes that we're building aside of that had data that we're actively querying through Spectrum. 2018, 2019, our velocity of games increased yet again. Our operational data lake continued to grow. You see the pattern here, kind of the trajectory of the data size. We're still doing a lot with Spectrum to pull data from S3 into and joining with and enriching that data we had loaded into the Redshift clusters. But if you notice, there's a little arrow pointing back out to that data lake, which we're now calling a lakehouse. We heard Andy introduce that in the keynote a few hours ago, and Mauer gave us a slide on it just a few minutes ago. So now we're actually taking some of that enriched data, pushing it back out into S3 so we can consume it from other Redshift clusters, but also from some other tools. In 2020 and beyond, watershed for us. Prior to that, our velocity of tenants was on a yearly basis. We've increased so much now that we're thinking of it in terms of months, right? Two new tenants a month. Now, you'll see here that our ingestion has gone from 24 hours to 3 minutes to 3 to 10 minutes to 6 to 10 minutes. You might think that performance is not that great for us there, but that's not the case. What's happened in the background is we've gone from that 4 or 5 data sources to 30. And for that telemetry data that Matt was talking about, when it first started way back in 2013, 2015, those games had like 20 tables that we were loading. Now we have games that load 300 tables. So the data has gone wider, right, in more than one dimension. So in order to kind of keep that practical, to kind of keep cost reasonable, we relaxed our load rate a little bit so that we could handle both the volume and the variety of data we're getting, but still keep cost reasonable. Okay, more of the same on our operational data store, continuing to grow. Today, it's about a petabyte sitting out there in S3. And we have multiple lake houses where we have those data lakes in S3 and data that matches them or sits adjacent to them in a Redshift cluster. And we're still moving data in and out of Redshift. Right? We're copying data in. We're also querying it, no load with Spectrum, but we're also pushing it back out with unload. Right? So I know any of you that have been Redshift customers for a while, it's probably 80% of us in this room here have been waiting for unload to Parquet, now called Data Lake Export. We're doing that, and it's wonderful, finally. So thanks to Redshift for that, and thank you, Mar. So we have to be pragmatic, though. Remember, we had different groups of folks on our teams that had different skill sets. We still have to pick the right tools for the job. And the tools are changing all the time, so we have to be pragmatic and change every once in a while. When it comes to integration, we're integrating SDKs from our data ingestion into our game clients to directly push telemetry data to us. Right? Some of that goes into client, some of it goes into game server backends. We also have integrations with a number of outside partners to be able to pull that data from them. For the telemetry data, we use Apache Avro, but not your typical Avro. We use a specialized version of it called fingerprinted, where the schema of the Avro is encoded in a little binary thumbprint. That's really important for those little game devices like mobile phones because they have pretty tenuous and low bandwidth networks. So we have to really respect the network capacity of those devices. And the fingerprinted Avro is the most bit dense form of sending that data. When we get to ingestion, we've got Spark sitting on EMR running Spark streaming. We provision that at a per tenant level, and we basically have a Spark streaming job that runs 24/7. The only time we ever stop it is if we need to upgrade the software for it. We use the Glue data catalog to be able to catalog that data so that then we can expose it to the query engines. And as I mentioned before on the elasticity and durability on ingestion, we use Apache Kafka on the inbound side to handle that. And we orchestrate it all with Airflow. Transform and storage, the Lakehouse sits in S3. Redshift sits behind that with lots of data in Redshift storage. And now with the new RA3 instance type, some of that can now even go out to S3 so that we can scale Redshift compute separate from storage. But we make use of Redshift and Spectrum there a lot. On the modeling side, we use SageMaker for machine learning. We pull data out of our Lakehouse, build a model on it, pull out some more data called a scoring set, score that data, push the scores back in, and that was Matt's last slide that was showing you that. And for that, we again orchestrate with Airflow. And we also use Looker, a third-party reporting product, because it does an awesome job of handling those last couple of OLAP transforms that we're probably all familiar with at one point or another from something like Cognos or MicroStrategy. It does a super job of handling those and just pushing all the work into the query engine. Now, what's EMR Presto doing here? Well, Matt mentioned this a little bit, but I just want to spend a few seconds talking about it. So when we have a game that is a microservice architecture, the state of that game doesn't exist anywhere. The parts of the state of that game exist in the backing stores of all those different little microservices. So we use today EMR Presto to bring that state back together again in a federated join that I affectionately call putting Humpty Dumpty back together again. We're going to be able to very soon shift that over to use Redshift federated query against those same data sources and be able to eliminate those EMR Presto clusters. On the consumption side, the tools that we give our folks out at the game and studio level, again, Looker, that does all of our reporting and dashboarding, and for the analysts, we give them the tools for the task they have. What they like, what they tell us they like, is they like Jupyter Hub for collaborative data exploration. They like RStudio to do detection of anomalies in data and to start to prepare data, do that kind of data engineering for data science. All right, I'm going to walk through our big data stack here, step by step. Sources, we've talked about these already. We have the game telemetry, marketing events, and those many other smaller sources. The top two are streamed in. The bottom one are all of those little jobs that go out and pull data from all those marketing sources, sales data from, you know, your Xbox and your PlayStation networks and so on. So for the game telemetry data that our developers, our game developers, actually build into their code, they instrument their own code to collect the data they need to do their job. That data comes in through a typical HTTP endpoint. You know, load balancer or EC2 scaling group are your best practices there. And that compute resource there does very, very little to the data. Now here you're going to notice a line of orange things across the top. And this is some of the stuff that we kind of call our secret sauce. Right? Schema version. We support dynamic schema modification. Anybody that's writing or developing telemetry data can change the schema of the data at any point in time. And we carry that all the way through to our back end with no human involvement except the developer that decided to change the data that he needed or she needed to do her job. We do that with a schema registry. Build time in the game, they register the schema. We know what the schema for data is before we ever even see the data. So we are prepared, ready to receive that data, and we transform any existing data for that logical event into the new schema before we see new data. There's our elasticity for our instant durability in Kafka, and we use Kafka for all that. Kafka here will hold about a month of data for us. We can have our backend go down, any part of it, and we never lose data. We fix it, we bring it back up, and we drain data out of Kafka. That keeps our customers happy because we never lose their data. They may have to wait a while if something goes wrong, but it will be there. Now, Spark Streaming is what does the consumption from Kafka, and we have schema management that goes all the way through the whole system to support that. We land that data in an operational data lake. And that lands in a Redshift loadable format. Then we've stuck with delimited text for quite a while for that, and we may or may not move off of that, but that works really well for copy commands. So now we load that data into Redshift, and you see up there another orange bar for our loader. There's a little bit of, if any of you out here are familiar with electrical engineering, what I like to call an impedance mismatch, right? We have we have a Spark streaming job out there dropping files into S3 at a pretty high rate, right? Now 10 minutes is not super high, but you know, it's 300 tables to load every 10 minutes, right? It was 300 tables to load every 3 minutes, you'd see where we might have a problem. But our loader there batches that stuff up into transactions and kind of matches that impedance with Redshift, so we can get that data in there as efficiently as possible. And all of these things here that you see, multiple instances, are the things that we provision per game. Okay, so that helps us with what I call our blast radius. Okay. A component for one game's processing pipeline can go down without affecting any other game. On the marketing events, a little bit different here because of the data source. We use an Akka framework program that sits out there again on another EC2 auto-scaling group. You notice here this one is single instanced, and that's because the source only supports one endpoint for us. Again, into Kafka. process that with another Akka framework job that runs on an EC2 auto-scaling group. Now we drop that data directly into the analytic data lake in Parquet. Now, I'm sure you all know what the next one's going to be. Spectrum, right? So here, no load, we pull it directly from Spectrum, enrich that very, very big source that we loaded into Redshift, and introduced another Redshift cluster type. For us, we call it our central warehouse. This is where we do all of the overall business reporting for our whole game slate. Right? So all of those eye candy dashboards for all the executives, they come out of that central warehouse database. Now we've got all those other data sources. There are quite a few of them, but their velocity and data arrival tempo is relatively low. Most of them are daily, so I put daily batch up there. There are a couple that are hourly. We take that data and we drop it into the analytic data lake. And it's mostly not transform data. We know the schema for that data. It doesn't really change. We don't have to deal with that creative part that we have with our game developers, where they're always changing what they're building, right? If we go out for, like say, user acquisition data from a data source, that's relatively stable. We drop that in S3. None of that data is terribly big. So delimited text is good enough. Right? Parquet there is kind of overkill. But now you see we pull that same data into central warehouse and also into those game clusters. Now if you notice here, those arrows, those green arrows and the purple ones coming out of that analytic data lake, they have two ends on them. This is one of the benefits of the data lake export, is now that we move data both ways. We bring data into one of these Redshift clusters, enrich it, produce another data asset or an enriched data product, push it back out to S3, and share it with the other Redshift clusters. So I like to call that data mobility. And again, the tools we use to consume that data match the skills of the data consumer. Okay, I'm going to talk to you a little bit about where we get value from Redshift. Typical word cloud here. Green here means what's new. These are the things you heard Indy Jassy announce an hour ago. Several of them Mauer had just talked about also. Elastic resize. Matt mentioned this. I'll mention it again. We use elastic resize all the time to scale up and scale down quickly. It allows us to add storage and compute on the order of minutes, where before a classic resize on a big Redshift cluster might take a day or more, right? A day or more was unacceptable downtime to our customers. You could imagine, well, as soon as you start doing a classic resize, first thing Redshift does is put that cluster in a read-only mode. What happened to our data ingestion? Of course it had to stop, right? So that's why we like elastic resizes. We get a very, very short interval of unavailability when the new nodes are provisioned. And then after that, the data movement catches up while we're still doing work. It allows us to respond to workload spikes very flexibly. I want to talk a little bit more about how to respond to that even more flexibly. And there's an interesting side effect. I don't know if you may have experimented with it with elastic resize. It's the only way you can actually change the number of slices on a node. You can use this to play with or experiment with. Having more or fewer slices on your node helps your performance. Sometimes when you have less, you get more compute and you can actually help your workload overall. WLM QMR, this is central to how we operate our Redshift clusters. Allows us to manage memory, but more importantly, it protects the cluster from those rogue queries. You've all seen them. You know where they come from in your organization. You probably get a couple of them a month. If you've done a lot of coaching and training of new folks on SQL, if you haven't, you probably get a couple a week, and they're not fun to deal with. Well, you can at least protect your cluster from the runaways with QMR. In our case, we also balance readers and writers. We segregate all of our writers, all of our streaming ingestion off into their own queue, guard the resources for that. line up the number of slots or concurrency with our loader process so that that just hums the whole time. In fact, if you look at one of our clusters doing data ingestion from our telemetry data, it's not never running a copy command. It also allows you to limit execution time to protect against those runaways. And ultimately, helps you meet or manage your SLAs. Concurrency scaling. This is your other way of adding storage and compute to your cluster. By now, you don't have to wait minutes. It's automatic. You just turn it on. And Redshift decides how to do it. The key to concurrency scaling is it operates on WLM queue wait time. And so the way I like to think of it is if you have a cluster and you have queues in it, and you're seeing a lot of queue wait on your queries, that concurrency scaling comes in and clips the peaks off, takes that work and runs them somewhere else. Now, right now, it's only read-only work, but in a busy cluster, you're probably running a lot of queries. And if you're just doing loading, what's the point of your cluster anyway? You pay for what you use. It's, as Maurer said earlier, sometimes free. For us, we have about 20 production clusters. About 15 of them, concurrency scaling is free. There's a couple that run a couple billing hours worth per week. And then we have one or two that can basically consume a concurrency scaling cluster full time. Right now, there's somewhat limited cost controls on concurrency scaling, is you basically just have an integer. It's like one cluster, two clusters, three clusters, and so on. So if you have one of those clusters that has really high queue weight and you turn on concurrency scaling, just pay attention to it so you don't get a surprise in terms of how much execution time you actually burn through. Spectrum, query in place, no loads. Right? Share data with other tools and data mobility between clusters, especially in the case where you provision per tenant. Right? You need to move data around, and Spectrum allows you to pull data into a cluster. Data like export allows you to push data out of a cluster in a readily consumable format. Data like export's new. We've all been waiting for Unload to Parquet. They gave us more than that. They made it partition aware. It allows us now to both put a lid or cap on the growth of the cluster, right? Up until this point, we had to keep adding more nodes to add more storage. That gets expensive. So we can put a lid on it and start sizing those clusters for the compute demand, and then take the cold, long tail of data and start pushing it out to our data, our analytic data lakes, and still query it through Spectrum. So the way you kind of do that is you build a union all view to put two parts of that table, logical table, back together again. Again, another way of getting mobility of data between clusters. And of course, it's an open source columnar format. The RE3 instance type, I would suggest you experiment with it. It does some wonderful things. Scale storage with no downtime. Redshift just takes care of it. Right? So you have storage elasticity in a cluster now that you didn't have before. And it's much, much faster than the node type it replaces, right? The DS2s. Because of the Nitro architecture, you get much higher throughput on that cluster. And you get more compute and memory than you had before for the same node type for the same cost. Now, we do a lot of work with the Redshift service team. We partner with them on a lot of features. I'm just going to show you here some of the areas that we have done that with in the past. Data lakes. Here's the features we've worked with them. The one thing I want to point out here, not Redshift, is that glue data catalog. Right? Glue means gluing the big data stack together. It is the hub of the wheel of the big data stack. Lake formation. They're bringing in a unified permissions model across Spectrum, Spark SQL, Presto, and Athena at the column and row level, first for an analytic column store. Cost performance. I mentioned WLM and QMR. CloudWatch metrics, they provide us quite a breadth of CloudWatch metrics. Of course, we all have our own special metrics, so we'll always want more there. But sometimes you have to build your own because they're specific to your use case. And the Advisor, a wonderful tool for those who may not be diving in as deep on Redshift. It'll tell you what you need to do to kind of get your cluster running quickly again. And again, look at that RE3 instance type. Operations, haven't really mentioned this anywhere else, but concurrent and trailing track, maintenance deferral, event notification. Hey, we know, well, they'll give us an event that tells us when our cluster is going to get upgraded. Now we can programmatically act on that. And if you ever need it, the ability to roll back a release. And again, the new console. So I just want to wrap up with AWS Listens. Here are the ways that you can get to work with the different parts of the AWS organization, whether it be support cases, service forums. Please, go read the forums at least. And if you know something there, you can answer a question, contribute. We all benefit from that. Your TAM is your hub to communicate to anything in the whole AWS organization. And your SAs are the ones that try to tie it all together across multiple services. And with that, it's been my pleasure to talk to you. I hope you found at least 1 or 2 nuggets that you can take home and make part of your own story. And we're hiring, and we'd love for any one of you to come be part of our team and be part of our story. And now I'm going to hand off to Mauer.
Thank you, Kurt. Thank you, everyone, for attending our session. Thank you, Kurt and Matt, for your inspiring insights about how to build scalable data analytics stacks with Amazon Redshift. I wish you a productive reInvent. Enjoy the time here and learn a lot. And do take the session survey. Thank you so much. Thank you. Thank you so much.